Hi everybody, welcome back. Let us try to solve some of the problems related to uh, that is on circle, which we are looking now. And the problem which we are looking here is that what do we have is if diagonals of a cyclic quadrilateral are diameters of the circle through the vertices of the quadrilateral, prove that it is rectangle. Please, can you draw a circle and draw the whatever is here mentioned, the diagonals of the cyclic quadrilateral. Here, okay. See that? Please look into that board carefully, as you are seeing here, and this is now a circle. Okay, circle is drawn. Circle is drawn here. Okay, and then afterwards, corresponding to that circle, again, this we are saying this as a cyclic quadrilateral. Okay, which is mentioned as A, B, C, and D. Those are the vertices of that, right? And there is a diagonal. Diagonal, yes, that the center is O here. Okay, so A, B, C, D is a cyclic quadrilateral. Okay, having the diagonal. Now the diagonal, which is what is it? BD and AC. Show me that BD and AC. Show in that figure. Yeah, BD and AC. And O is a center, right? Now angle BAD is angle BAD. Write down angle BAD here. Angle BAD is half times of angle is equal to half times of uh, equal to half times that is BOD. Okay. Now what is BOD? What is it? 180 degrees, right? 180 by 2, right? What do you get?
90 degrees.
90 degrees. Uh, Now BD is what you have considered BD as chord, right? Considering we are considering BD as a chord, right? We are considering it, correct? Now next, what we have to do? Angle BCD, okay? Angle BCD, angle BCD plus angle BAD, angle BAD is equal to 180 degrees. Is equal to 180 degrees. Correct? Show me that there. Angle BCD in the figure. Angle BAD. Yes, which is 180 degrees. You add that, that is equal to 180 degrees. So angle BCD is what? Is equal to what is given? What you have found here? BAD, angle BAD. So BCD is, find out
180.
180 minus
90.
90. Do that. One 180 minus 90, which is equal to 90 degrees. 90 degrees. And now let us take angle ACD. Angle ACD. Yeah, ADC. angle ADC plus angle
Half.
is equal to half times that of is equal to half times that of what is that?
UOC.
EOC. Okay. Angle, no? Angle. Yeah. Angle AOC. Show me that where you have AOC. Yes. So that is what is that? 180 degrees. So 180 divided by 2, which is
90 degrees.
90 degrees. And here, what you have considered? What is AC here?
ABC.
Chord. Considering
Chord.
AC as a chord. Please remember that. Okay, very important. Here we have considered BD as a chord. Here we have considered AC as a chord. So here you got 90 degrees. Here you got 90 degrees. Likewise, you have to find angle ADC, angle ADC plus angle ABC. Right on, which is equal to
180.
180 degrees. Good boy. Now from this, what you know? What is this?
ABC.
90 degrees. So angle ABC you get. Right on. Angle ABC is also
90.
90 degrees. Right on. Angle yes. Angle ABC is 90 degrees. So I hope you understood this. Okay. So at last, what we have to prove? It is rectangle. So hence it is rectangle. Hence it is hence 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 it is rectangle. Okay, understood, right? So I hope everybody understood this. Let us move on to the next problem here. What do we have next problem? Now in this uh, uh, in this you have if what do we have in the next problem? Let us see that. Next problem we have if the non-parallel sides of a trapezium are equal, prove that it is cyclic. Okay, you have to prove that it is cyclic, correct? So first what you have to do, you have to draw, first you have to do parallel lines, right? So what is that? Yes, yes, good. And now write the points there. What is that? A and B. And what is this point? Okay. So after that, you have to join that. Join that. Yes. This is a trapezium here. So write down ABCD is trapezium. ABCD is trapezium. ABCD is trapezium. Okay. I hope you understood this here. What we have done is you have drawn a trapezium here, which is ABCD. Okay. Now, what you have noticed here, AB is parallel to CD, correct? Write down AB is parallel to CD. AB is parallel to AB is parallel to CD. Parallel to CD. Good. and BC is equal to AD. Show me in the figure what is BC and A. Yeah, correct. Good. So now after that, draw a line which is perpendicular. Draw a line which is perpendicular that. Okay. What is that point? M.
Yeah.
And another perpendicular which is now AM is perpendicular to
B. Yeah.
AM is perpendicular to CD, right? BN is perpendicular to
Yeah.
CD. Write down. AM perpendicular to CD and BN perpendicular to CD. And BN perpendicular to CD. I hope you understood this. What we have done here, AM, AB. First, AB is parallel to CD, right? And then afterwards, we have drawn AD and BC, which is equal, and we have drawn that as a ABCD, which is a trapezium. And then afterwards, what we have done, M, we have put. So AM perpendicular to CD, and next is BN perpendicular to CD, right? So I hope you all understood this. Now we have in a triangle AMD, in a triangle, head on, in a triangle AMD and triangle BNC and triangle BNC. Okay, these two are I am considering, so it is AND. Okay, now we have been given as AD is equal to BC, which is already given, right? That's what we are trying to write. That is given. That is given, right? Given, correct? So next, angle AMD. Angle AMD is equal to angle BNC. BNC. Each is what? 90 degrees. Is 90 degrees. Okay. Now you do here. Okay. Continue it here. Okay. Let us do the next part of the problem. What is it? AM is equal to BN. AM is equal to BN. Why? The perpendicular distance between the parallel lines. Okay. Perpendicular distance between the parallel lines. Okay. Now triangle
AMD.
AMD is congruent to and triangle
BNC.
BNC. What is that? Right hand side RHS congruent rule. RHS congruent rule. Congruent rule. RHS congruent rule. Okay, leave it. Okay. Now let me move on to the next part of the problem. What do we have? Angle ACD is equal to angle BCD. Angle ACD is equal to angle BCD. What do we have that? That is CPT. CPCT. What is that? Corresponding parts of congruent triangle. Corresponding parts of congruent triangles. That is very important. Okay, keep that equation 1. Okay. Next, angle BAD
plus
plus angle ADC
ADC.
is equal to 180 degrees. Why we have considered? Because BAD and angle ADC are in the same side, okay,
AD.
of AD, correct? So that's all. Now,
Equation 2.
yeah, equation 2. Next, we have angle BAD plus angle BCD is equal to 180. Write down.
BAD plus BCD is equal to 180 degree.
180 degrees. Using what equation? 1. Using,
Equation 1.
yes, using equation 1. Therefore, opposite sides are supplementary. Therefore, opposite sides are supplementary. Therefore, we have ABCD is a cyclic quadrilateral. So that hence it is, yes, show me in that ABCD is cyclic quadrilateral. Hence, we are done. We'll move on to the next problem here. I hope you understood this. Okay. Okay. Let us move on to the next problem. Now, next problem is, let me read out for you. Two circles intersect at 2 points B and C, at 2 points B and C through B, okay, through B and C, okay, through B and C, okay, two line segments ABD and PBQ are drawn to intersect the circles at AD and PQ respectively, AD and PQ respectively, which is, I am trying to figure it out in the given problem. Let us prove that angle ACP is equal to angle QCD. Okay, I hope you understood this. Okay. So, please look at the points carefully. You have ABD here, ABD, correct? And you have ACD here, correct? And the PBD is there, right? So hence we have put that here. Now, yes. Now join the chords which is AP and DQ. Put that chords AP and PQ. DQ. Sorry. AP and DQ. Join that chords. Join the chords. Okay. And you join AP. This is a chord. Again, this is a chord. Join it. Okay. The joining is done, right? Now for the chord AP, and for the chord AP, angle PBA, for the chord AP, angle PBA is equal to angle ACP. Angle PBA is equal to angle ACP. Now, why the angle in the same segment? Angle is in the same segment. Is the same segment. Keep that equation 1. Consider this as 1. Now, for chord DQ, for chord DQ, okay? Yes, this is chord DQ. Please show there in the diagram what is DQ. Yes, that is DQ. I hope you understood that clearly. Yeah, good. Correct. Perfect. Now, angle DBQ. Angle DBQ is equal to angle QCD. Angle DBQ is equal to angle QCD. Angle in the same segment. Again, that is same. Okay, that is same. Keep that equation 2. Okay, angle is the same segment. Okay, that's done. Now let us move on to the next here. Now ABD
and PBQ.
ABD and PBQ are line segments intersecting at B. Are line segments intersecting line segment show me where it is intersecting, which point? B is the point. Okay, at B, at B, correct. Okay, now angle PBA, angle PBA, angle PBA is equal to angle DBQ. DBQ, vertically opposite angles. Vertically opposite angles. Vertically opposite angles. Okay. Now keep this equation 3. Okay. Keep this equation 3. Now considering equation 1, equation 2, and equation 3, what do you get? We obtain what is that? Angle
QCD
is equal to angle ACP is equal to angle ACP. Okay, so here what we have done, here two circles were there, and what all we have done? Two chords are there. What are the chords? AP
and DQ.
DQ are the chords, right? Then what we have done, we have got the equation 1, which is angle PBA
and
is equal to angle ACP. Okay, and afterwards we have got angle DBQ is equal to angle QCD. Second, equation 2, and equation, this is equation 3. Okay, not this. This is the intersection point. Okay, where you got intersection point. Where is it? Where you got intersection point at B. Show me that. Yes, at. Okay, so hence we have got equation 1, equation 2,
and 3.
We obtained angle ACB is equal to angle QCD. So hence we have proved it. Thank you for listening, and thank you for yours.